Hello and welcome back to the channel. Hey, I'm Ron with Ideal Industries, and in this segment we're going to talk about Ideal's testers and meters, and specifically Ideal clamp meters. And when you look at clamp meters, for measuring specifically AC amperages, basically, and that's the main reason we use them for, they're called a clamp meter because they have this clamp that will clamp around a conductor, and we can measure that current flow safely. Now, these testers do a lot of other things. They're basically a digital multimeter as well. And this particular one is the Ideal 61-746. And this tester, as I said, is a clamp meter. It will go up, measure up to 600 amps, so it would measure for industrial applications as well. It's a true RMS meter, which I'll get into in a minute as well. And it also has a lot of other nice functions, you know, non-contact voltage indication on the top. It's got a whole button on the side of it. It's a Cat 3 tester, which is really a good, really nice level tester for really even a pro that might want to buy a tester. So it's got a lot of nice functions to it, and it comes with this 2-year warranty as well. So let's take a close-up view of the clamp meter, and I'll walk you around the tester and show you how to use it. Here's a close-up view of the Ideal 61-746 clamp meter. And clamp meters get their names from this distinctive clamp that opens up so that we can clamp it around a conductor and measure AC currents safely. And when you look at the tester over here, it says 600 amps and it says 600 volts, so it's actually a 600 amp clamp meter, and we'll measure up to that. We have a clamp over here, and then down below that it says Cat 3. And you'll also notice on the bottom of the tester you got in front of that you bought, it says Category 3 as well down there. Now, Category 3 testers give me an indication of where I can safely use the meters. And Category 3 meters can be used in electrical distribution panels, out to feeder circuits feeding other panels, to branch circuits feeding outlets and rooms, to appliances and other devices, and even into low voltage. So the meter is pretty useful. Now, you'll see here it's a true RMS meter as well, and true RMS basically is what's recommended by the National Electric Code. You'll find that the power running through, AC power running through, buildings, office buildings, industrial plants is not as clean as it could be, and even in homes as well. And this is caused by a lot of different things, caused by harmonics, we call it. But essentially what it amounts to is that waveform we're trying to measure is not as clean looking as it could be. And a lot of meters would have trouble measuring that accurately, and true RMS meters do that accurately. So this is a great little meter even for the pro. And when I look at the meter, one of the first things I'll see here is two ports on the bottom of them. And if I'm going to go through a couple of the functions with you here, the black one obviously always goes into the black one. The red one would only go into the red lane, and you only have those two options. Now, you'll notice on the tester there's a symbol right here, and one of the things I'll teach you is to automatically go to that setting on the meter. And it's in its continuity setting is what it is, and it's checking for continuity. And what I'm going to do is I'm going to take the two test leads, touch them together, tester goes to 0, and I get that audible tone. That tells me the tester's working, the test leads are in good order, and they're functioning, everything's working, and the meter's safe to use. And so you might do that first thing anytime you turn on a meter, just to make sure the meter is working properly. Now, you'll notice on the display here it says OL, meaning overload. It sees so much resistance it can't measure it. Right below that is omega, so it is trying to measure resistance. Now on the top left here is a button to turn on and off the range, and this little button right here is the ranging. And normally the meter will go into auto ranging when we get into the voltage or ohms or the amperage settings, but I could turn that on. So if that's on, auto ranging's been turned off. Now here we have an audible symbol indicating that the meter will give us that audible tone, and then right next to that it says APO, and APO is auto power off, and the meters automatically shut themselves down in 10 minutes if nothing's changed, and just to save power. So if you accidentally leave them on, it'll auto power off. Now if I want to turn that function off, I turn the tester all the way back off to the off function. I'm going to hold the range button down. I'm going to turn that function back over here, and it turned it off. And you see the APO is gone. So if you want to ever turn it off, you can. Now, while we're in this setting, the continuity setting, we can use continuity to check a lot of things, and one would be a simple light switch. And here's a light switch that, if I throw the switch there, I should have nothing across the meter shows me nothing, sees an open in the circuit, and was what we expect. And if we throw the switch, it should go to 0. Tester gives me that audible tone again, and again I know that light switch is good. So we can measure that. We could also do things like simple fuses, and here's a little fuse that I can actually go across here and and measure that resistance across it. Oops. There we go. Show me about 5 ohms. And it give me that audible tone, so again I know that fuse is good. So those are a couple applications where we might use that continuity setting. Now right above it is the omega symbol, which indicates resistance, so it's going to start measuring resistance for me. And again, it's in the mega ohms, and you'll notice that little button on the top left has gone away, meaning the auto ranging is on. And if I need to measure the resistance in a device, and we can use that for measure resistance in a lot of devices, obviously an open is a would give me an indication like OL, and then they'll other than a direct short, which would be about 0, there'll be some resistance across really almost any devices here. And when I go across a little resistor here, I'm seeing about 178 ohms, okay? And the two resistors side by side here are actually in series, and if I go to the other one, it's showing me 0.358, and then it says kilo ohms or thousands of ohms. So the tester's gone to auto ranging, which will automatically go in the next highest setting for it. And there's a 200 ohm setting and a 1000 ohm setting. So it automatically went to kilo ohms. So 0.358 kilo ohms is 1000. So we move the decimal point 3 points to the right, and it would actually indicate 358 ohms. And if you wanted to go through the ranging functions, you could turn the range button on. You notice the range light is lit up here, and I've hit this several times. I'll get back into, and it's in kilo ohms there, mega ohms, and now it's back into ohms. And if I go across this, it's indicating about 360 ohms, which is what I really wanted to read. So anyway, there's an idea or a place where we might actually turn off the auto range. And if I push the button down and hold it, auto range button went away, and auto ranging is back on. Now, if we wanted to measure some voltage applications, we can do that as well, obviously, with the tester. And I'll take the dial here, and we'll go to the top one, which was the V with the straight line and the little dotted line above that, which is actually measuring DC voltages. Okay, and you'll see over here the meter says DC, and of course beneath the numbers it says V for voltage. And if I wanted to measure this battery right here, I can take my test leads and go across the battery. And it's showing me about 9.8 volts DC across the battery. Now, if I have my test leads backwards, you have that positive and negative with the DC voltages. You'll see that negative symbol has lit up now on the far left above the DC, meaning I'm reading a minus 9.8, which is actually just I have my test leads backwards. So there's an application where you might measure some DC voltages. Now, if we want to measure AC, we can do that as well. I'll take the tester and move the knob to volts AC, and you see the squiggly line there, which is indicating AC. And again, the tester will say AC over here. And I'll take my little test leads and insert them in my outlet here, and we should get a reading there as well. And again, showing me about 120.3 volts across that. And again, it's going AC. And if I take my test leads and reverse them, it's still going to give me that same reading. Okay. And then we were testing some basic AC with the tester. Now, obviously, the tester's real main function being a clamp meter, and I'm going to take these test leads out of the tester here and turn the tester off. And let's talk about measuring amperage. Now, to measure amperage with either a digital multimeter or a lot of testers, you have to make the meter part of the circuit. It has to be measured in what we call series. Okay, and so to do this safely, we will use clamp meters. Now, the distinctive idea about a clamp meter, it'll clamp around a wire, and we can measure that AC amperage running through that. Now, if we try to clamp around the hot and the neutral, that's not going to work because the magnetic fields that the meter is going to try and read are equal and opposite in the neutral and the hot. You clamp either over the hot or the neutral, but not both, because the magnetic fields coming off those wires are actually in opposite polarities, and they will cancel themselves out. So we've got to be able to split that. And so I'm going to take here a device called a line splitter. and insert it into my outlet over here. And this is a device that does that for me. And you'll see here it says, one says times 1 and the other one says times 10. If I clamp the meter across the one that says times 10, it would give me a 10 times the actual reading. So I'm going to use the one that says clamp 1. So if we're actually measuring very small amounts of current, that might be useful. So I would have to clamp the meter around one of the two, okay? And it's going to give me a reading when I make a measurement. Now I can't make a measurement because if I turn this to amps AC, 40 or 600, I'm going to be measuring some smaller amperes, so I'll leave it at 40. The meter gives me nothing, and the reason is because basically there's no current flow happening here. So we got to measure the current flow through device. Now if we want to do that, I've got a little hairdryer over here that we can plug into the top of the line splitter, okay? All right. And when I take my little hairdryer and turn it on, whoops, okay, I've got a cool setting here, a medium setting, and a hot setting. And on the bottom of it is turn it on, low. The hairdryer here is pulling a little over an amp, okay? And if I take the heat circuit and turn it to medium, you notice it jumps up a little bit, pulling about 4 amps, a little over right now. And if I turn it all the way to hot, the hairdryer is pulling just a little over 7 amps. Okay? And if I turn it back down to cool, it drops back down. And if I turn the hairdryer on high, on the cool setting, it's pulling about 2 amps. Medium, it's pulling about that 7 amps range. You know, and high, it's now pulling closer to 13 amps. So obviously that little hairdryer is pulling quite a bit of current. And that's sometimes when those circuit breakers pop because you've got multiple hair dryers going at one time in a house. So that's one way of going about measuring the current flow through a device. And again, keep in mind you always need to split the hot and neutral. So if you go back into an electrical breaker panel and you're doing this kind of a testing, that's what we would want to do. And again, it will measure up to 600 amps. By the way, there is a hold button on the side of the tester here, so if you ever got a reading and you can't quite look at the tester at the same time, you can push the hold button and the tester will hold the reading it last saw. You also see over here a NCV button indicating non-contact voltage indication. And what that is will do for me is the top of the tester has a point to it here. And if I'm pushing the NCV button down, I'm holding it down, and I can hold it up to AC, it will make the beeping noise at me that I'm close to AC. So it's a non-contact voltage indication to me. And I can go across the two ports here, and I can actually hear the louder of the two is definitely this one, which is the hot leg on me. Okay? Okay? So we can use that to indicate, is there power present near the front of the probe? So again, did I hit that right circuit breaker or not? That's a quick indication about whether or not there is actually electrical power present. Okay? And the little light here light lit up as well. So I can do that really in any setting I'm using. Okay? So that's what the NCV button is. And there you have it. That's the Ideal 61-746. And thanks for coming to another segment. Hey, I'm Ron with Ideal Industries, and we'll look forward to seeing you the next time.